So I did this talk a few times, and I've realized that trying to show how hardware works without you actually doing the hard work is actually very boring. Because I'm in front and trying to show you a blinking LED, and I'm super excited, and you guys are not. So I was hoping for a lot less people, because this is usually the talk where nobody attends, because it's like the one that is useless, but fun. So I have about 20 kits. So you guys will have to probably make new friends today, which is great. So I'll start distributing those. And what we'll do today is that we'll go through that. Like we'll do like a power workshop within 1 hour. You guys will all be Arduino pros after that. So I'll just go around. I'll pass them along. It's easier if you have a laptop, of course. And it's also easier if you have a Windows computer with Node installed. So that will save us a little bit of time. I'll just go with one per row for now. You guys want to pair up maybe? Right? Does anyone have a laptop here? Anyone in this row? Right, does anyone? Perfect. There you go. Right, does anyone have a laptop in this row? Cool. All right, there's one at least, so that's good. Let's just pass it around. This one here. There you go. All right, as I've mentioned before, I did this. You don't have a computer there. All right. Well, I'm sorry. You'll kind of have to look over somebody's shoulder because it might get boring if you don't have a laptop. All right, I'm getting there. There's one over there. Did I miss one? All right. I will be taking them back afterwards because, yeah, well, but I have something else afterwards. I still have a few left, like 3, 1, 2, 3. We're good. Put one here. So one in the front. There goes there. Another one over there. All right. Nodebots. So when I was a little bit younger, that was a few years ago, I was really fantasizing about this whole world dominated by robots. It was like my big thrill when I was a kid. I was watching a lot of sci-fi movies, and I was building costumes with big boxes for my little brother, and I would just strap everything on him and make him walk around the house talking like a robot. I wish I would have had a robot instead of a brother, but hey, take what life gives you. And eventually I kind of grew out of that, and I said, yeah, well, that's only things for kids. And I went to do software development, got a real job, and slowly my dream of building an army of robots to dominate the world slowly faded away. But just a few years ago, I've discovered Arduinos and like super cheap electronics. And I've realized that I was finally able to start poking around and hacking little things together in order to build that army of robots. So what I want to do today is to share that knowledge with you guys, so eventually you'll all be able to contribute with me to my Robocalypse. So welcome to this talk. Let's start with a little bit about me. I'm a technical director at Spiria. We're a software company based in Ottawa, Canada. This is our office. It's a super cool office space. It's an old church, very, very old. It was built in the 19th century, so it's actually older than our country. And as I was walking through Munich, I kind of realized that, well, it's not that old. But anyways, it's a very nice place. So if you're ever in Ottawa, Montreal, or Toronto, let me know, and I'll be more than happy to have a chat with you. All right. So moving on. So there's a few new people that just came in. So as I was saying, I already gave that talk once, and I found that it was not very dynamic. So me in front of everybody trying to show you a blinking LED is not the best way to do this type of talk, I think. So I went and bought a bunch of Arduino boards. and I still have 1 or 2 left. So what I'll do today is that I'll get you guys to do the hard work and to actually code the thing and see how that works. Is there anybody that just arrived that has a laptop with Node installed that would like to try one of the kits? I've got one here. There's one over there. All right, I'll be there in a minute. Okay. And I'll run a lot, so I might lose my breath a little bit today. So what we'll be talking about, I'll show you a little bit, a little demo of what we'll be doing. Who was it over here? Sorry. And we'll talk a little bit about the hardware that we're going to use. We'll go through the software, and then I'll get you guys to do the work. So we'll set up an Arduino board. Actually, this is already done for you guys. Then we'll set up the project, and we'll build our first Hello World. And if everything goes well, we'll build a full nightlight. So exciting. Typically, the last few times that I gave this talk, about 50% of the people get all the way through it. So don't worry, and if somebody's stuck, I'll kind of just still move on. Sorry. I love robots. I have my little pet robot that I usually bring along with me. It traveled the world, and it got quite a few beat-ups, and has a lot of duct tape on it, and it's just past traveling in now, so I'm not bringing it with me anymore. Just another little travel tip. If you ever have the idea of traveling abroad with 25 kits with Arduinos and a bunch of cables in your luggage, check your luggage. Security does not appreciate. And apparently they don't know what an Arduino board is. But okay. Robot shop, this is where I usually order my parts. I told them that I'd plug them just because they were nice enough to give me a nice kit. So what I'll do today, and that's why I said, bring me back with my, my little kits that I gave you, and I'll hand this one out at the end of the talk. What I'll do is that the first team to be able to build the whole thing will get the little kit here, the Arduino kit, and then it'll be up to you to decide who gets it. All right. If everything goes well, this is what we should be building. So basically a night light. So when there's no light, the LED goes on, and if there's light, the LED goes off. All right, so once you're able to do that, you're able to control outputs, so a LED, with your Arduino and using JavaScript, and you're able to control a sensor, so an input, which is the photo sensor in this case. So after you've done that, you can basically do everything. Building a robot that has wheels and detects and moves along the house, autonomous, wow, it's too early. Autonomously is basically just the same thing. So it's a bunch of sensors and a bunch of inputs and a bunch of outputs, and they pretty much all work the same way. So once you're able to do this, you can do anything. In your kit, this is what you should have. Sorry, so an Arduino board, USB cable, one breadboard. This is this little thing here. Jumper cables, 2 LEDs. Resistors, everybody knows how to distinguish the different resistors and the value on the resistors. So there's color bands. Everybody knows the color bands by heart, right? Right. So you have 2 that has 2 red stripes. That's the 220 ohms. And you've got one that has another color schema, which is the 1K. The only reason why you have 2 is to distinguish between both. So I made it a little bit easier for you. All right, hardware. So when you want to build little robots or little IoT stuff, you'll need a microcontroller, ideally a programmable microcontroller. And in this case, we're using the Arduino. So Arduino is an open source software. Use a NatMega programmable chip. Very, very easy to use. You can program it in C. There's a free IDE that comes with it. You basically just plug it in. You can program something, and off you go. So it's very, very, very easy to use. You've probably also heard about Raspberry Pis. There's a bunch of different, let's call them microcontrollers available. Raspberry Pi is more of a computer. So Raspberry Pi has the full operating system. So it's good if you want to build a media center or your SNES emulator or something like that. So it's good for that type of project that require a real software to run on. Arduino, on the other hand, doesn't have an operating system, right? So it just runs the application that you just wrote in a loop very, very quickly. So it's very good if you simply have inputs and you want to do some output based on that. So if you just want to interface with hardware, it's very, very easy to use, and it's definitely the way to go. Now, I said it programs in C. We're at the International JavaScript Conference, so we'll try to program that in JavaScript instead. So the Arduino has a serial port. So you'll notice on the board there's a little RX and TX, two little ports there. And you can use those to communicate with your computer. When you connect your Arduino to your computer through the USB cable, it actually uses that serial port in order to communicate. Once you have that, you can use a standard protocol, which is called a standard for MANA. And then you can use that to communicate with your Arduino board. So using that, you can send instructions to your Arduino in real time, and the Arduino will actually respond to that. Breadboards. Just a quick thing about breadboards. So just to understand how it works, so basically, everything that is linked together here, they're all connected together, right? So imagine a metal plate underneath, and it connects all those 5 dots together. Same thing here, and same thing here. They are not connected across like this. Okay, so really they're connected like row 5 is all connected together. You'll need this when you'll connect your circuits and your jumper cables. So basically, if you plug something in F5 here and something in J5, they're connected together. Right? So it's just as if you would stick them together. If you connect something in F1 and something in F5, they are not connected. All right? Everything on the 2 lower rows here, so the big minus and the big plus, they're all connected together as well. It doesn't have to be minus or plus for the electrical current. It doesn't matter. But they're all connected together. So if you run out of jumper cables at one point, it might be because you're not using this one. Resistors, everybody remember Ohm's law from high school, probably. Yeah, it's just boring stuff. No, seriously though, just an interesting note, just to kind of know how it works. So you don't want to send too much current into an LED or any other sensor because it'll blow up. It has like a very distinguishable burn smell, so you'll know it if it happens. And you can measure the value of the resistor that you need in order to not burn those components by using this equation. But in reality, you just Google stuff and you find the actual value by doing that. And it works. But just so you know, for a LED, you need the 250. I'm using 220, which is close enough. Software, Node. Everybody knows Node? Hopefully. All right, a few people, that's good. All right, so Node runs on Chrome's V8 JavaScript engine, so it essentially lets you run JavaScript on your desktop computer. That's it, open source, yada yada. NPM, everybody knows NPM as well, hopefully. So NPM is the package manager for Node, lets you download stuff. And Johnny 5. Johnny 5 is the one library that we will be using to communicate with our Arduino board. Johnny 5 is a very impressive library to communicate with anything hardware. Very, very well done. It's event-based, so you can declare a bunch of different things, and you can trigger different events based on whatever is going on your board. It's compatible with the Arduino, of course, by default, and it automatically detects the Arduino if it's plugged in your USB. But it also works with Raspberry Pis, Tesla boards, particles, a bunch of different microcontrollers and mini computers. Yeah, and all the documentation is there, very, very well documented. You'll have schematics for pretty much everything that you want to build. Very cool library. So definitely, if you want to do hardware using JavaScript, by all means, look it up. And that's what we'll be using today. Project setup. All right. So I already mentioned if you want to communicate with your Arduino using your serial port, you'll need to use the standard format. So I've put it there just in case you want to look at the slides afterwards, but I've already did this step on all the boards. So essentially, you just need to plug it in, open the Arduino IDE, you download this application, and you just install it on your Arduino. So that's all there is to do. Once it's there, your Arduino board is listening for instructions, and then you can communicate using Johnny 5 that will communicate through the same protocol. All right, let's get ready. So everybody has their stuff. There's a few people that just joined in. I think I might have one kit left. All right, so just open up a terminal window and create a new project. Do an npm init, and just accept all the default values. And then you can install Johnny 5. Is there anyone that wanted to try it here? Right, so npm install Johnny 5 afterwards. And it should give you something like this. And the choice of color might not have been the best. So. Right, so as I mentioned already, if you're not the one with the things, you'll probably need to make some friends just so that you can kind of overlook over somebody else's project just to kind of get a sense of what's going on. How's it going with the npm install? All right, so you should get something like this. And we will work on Hello World. Hello World in the hardware world is just making a LED blink. So, yeah, and it's about just as exciting as any other Hello World, but this is what we will do today. Right, so the first step is to plug in your Arduino, or actually, sorry, unplug your Arduino, build your circuits, and then plug it back in. So from the ground, you will plug to the short leg of your LED. Right? So you'll notice that your LED has a short leg and a longer leg. So from ground, you go to the short leg. And from the long leg of your LED, you go to your resistor, your 220 resistor. So it should have two red bands, remember the 220. And then from your resistor, you go to pin number 13. Right? So the Arduino has a bunch of different pins, numbered from 0 here all the way to 13. So you'll plug it back into LED 13. Which is also interesting is that the Arduino has a LED right here, and it's also connected on pin 13. So if you want to test something and you don't have a LED ready or close by, you can actually just run the same application and you should see this LED running out of the box. The what, sorry?
The long leg of the LED is where?
The long leg of the LED is the one that goes to the resistor. I realize that this is a great talk for me. I don't have to talk too much in the morning. Do you want to try it here? I only have the boards left. I don't have the kits. But still, this one, as you plug it in and you run the first code, the LED should blink on it because it's connected to pin 13. Right, so I still see people looking at the screen. Right, so I see that some people are done with the wiring. Some people are not. Some people are like, dude, you're way too slow. Come on, move it up. The slides are there. So all the code is there and the slide. So just take a look on my GitHub. And you can actually download the slides. And you can move at your own pace if you'd like. So I'll just leave this one on for a second. And I'll go back to the wiring. Okay, so we seem to be pretty good with the wiring. Like I said, just go and download the slides if you will. And we'll move on. So when we use Johnny 5, and I'll show the code in a better color schema in a minute. But we'll just go line by line through the whole code of our hello world. So you start by requiring Johnny 5, just like you would do with any other Node library. So require Johnny 5, and then you declare your board. The board is is your Arduino in your case. This is what we will be using. You can pass it some parameters here. So if you had a Raspberry Pi, like I mentioned, you would pass it some parameters to say I'm using the Raspberry Pi instead. If you wanted to use it with Bluetooth or Wi-Fi instead of plugged into your serial port, you would pass it some options there to tell it to communicate via another medium. And then, like I said, Johnny 5 is event-based. So you've got your board event ready. So on ready, and you have a callback. You declare your first LED. So new J5 LED, and you pass it the number of the pin to which the LED is connected. So in our example, we've connected it to pin number 13. If you were funky and you decided to plug it somewhere else, then just pass it the right pin number here. Like I said, pin 13 is also the LED that is on the board, so you'll see it flash as well. And then you have LED.blink. So the LED has a blink method, which will, as you might have guessed, make the LED blink. And you pass it the number of milliseconds between the toggling of states. So 500 milliseconds, and the LED will blink. Can you guys see that one? Especially in the back? Right, well, it looks like it'll have to be the PowerPoint. I'll leave the PowerPoint for now. If it's really too hard, we'll switch back to the code. Some people have had some issues on Macs earlier, or I've seen that. So if that's the case, you can try to follow that link. Install the driver, and it might help, hopefully. Most of the time, it helps. That's why I was asking for a Windows PC ideally at the beginning. But it's not a general problem. So usually if you buy a real Arduino, it's not an issue. It works with a Mac very easily out of the box. If you buy cheap imitations from China, because I was way too cheap to pay 10, 15 bucks each, because I'm afraid I'll lose a few, that I bought some cheap clones in China, and some of them seem to be having issues. All right, do we have blinking LEDs? And I wanted to hear somebody scream, woo! If If it's what, sorry?
It's a driver on the board.
It shouldn't need a driver. It shouldn't need a driver. I don't know if this one is available for PC as well. Like the only people that I've seen that needed a driver of some sort, you might want to try that. Like I said, we will lose people along the way, so I'm sorry about that. No, you don't need to flash anything.
Okay. We have a problem connected to the board.
I cannot see the problem. This is the problem. You can switch the position of total and also the two of the blue. Yeah, I mean just switch it like this.
Of course, you need to run this with Node, right? I forgot to mention it, but just in case.
It's also looking for connected device. It's Windows.
I don't know. You're the second one. You can maybe try with the other computer. That's what I would try at this point. And cross your fingers. Oh, come on. At least one person needs to do it.
They're all looking for device, I guess.
Yeah. Well, it usually works, I swear. If you have two plugged in, it might... Okay. Okay. So if you go through the slides and you can download the driver and try it with the driver instead. Like Macs have notoriously been giving me a hard time.
Mac always gives somebody a hard time, right?
Is it? Yes, we have one. All right.
How do you install the Arduino server?
You just run the Node script, and it should just do Node, whatever the name of the file.
Okay, cool. I'm going to connect.
I'm sorry.
So then it stops.
Okay, so, and then run Node.
All right, you're going to run this and then it hooks into this.
No, that should work.
Or doesn't want to connect to the device at all.
Okay.
Well, you don't get any error message whatsoever. You installed Johnny 5?
Installed Arduino, I think. 25, yeah.
Okay, try installing that driver maybe. So there's a link right there. Like if you download the slides, it will be easier than typing it in. But
Yeah, sure. This doesn't actually require Arduino Studio, right?
no. All right, I swear it works better than that usually. And people really get excited. Oh, we got another one here. So you've got two.
We are blinking.
It blinks and then it stops.
Filmer.
Okay, we'll let it finish this.
We do know what this term means. Like, what might be the problem? Selling some.
The connection couldn't be established, but we don't know why.
Yeah, it just times out. I've never seen that on a Mac, so I meant.
This is not Mac, this is Dell.
Well, on a PC,
Windows,
sorry.
Windows.
Yeah, that's what I meant.
Yeah, it's kind of weird. But it's not about the code, it's about the device. It's kind of weird.
And nothing is blocked on your computer. You kind of have full admin access to it.
No, it should just Windows.
We'll retry it on the Mac.
Okay, we'll try the Mac.
Okay, so we've got a few blinking LEDs. 1, 2, 3. No, it shouldn't be that long.
Okay. Is that the problem?
There's just warning, so it shouldn't be an issue.
We could download this Chinese thing.
Yeah, that's what I would try with the Mac.
The Mac is really not to work. And you trust that Chinese side?
Well, I've had it on my computer for a while, and as far as I know, there's not too much information.
Mining, right?
It might be coin mining on my. So I installed the driver. It will start mining coins for me. Thank you.
Ours doesn't connect at all. So
Okay, so there's a few people that just can't connect. I don't know why. On PC, I'm actually surprised. It usually works on PC. And then I can't troubleshoot every one of them.
I just have another question. This code is compiled to C and then uploaded to board?
So what this code does is that it actually connects to your board and it uses a serial port to send the instructions. So the Arduino at this point is only listening for instructions. So if you unplug your Arduino, it will stop working. Well, one, because it doesn't have power anymore, but also because it doesn't receive the instruction. It works? All right, we've got another one working. Fortunately, you won't be able to plug in the other sensor, but at least you've got a little bit working, got half of it. Okay, so we'll continue and we'll move on and we'll try to install a sensor now. We've got about 15 minutes left. All right. So what we want to do now is to build a sensor. So Arduino has two different types of sensors. It has digital inputs and outputs. So the pins that we've used, numbered 1 to 13, are digital inputs or outputs. So you can set them to both. And digital, just in case you don't remember your electricity classes back in college, it's a signal that is just a 1 or a 0, right? So you can send an impulsion to it to tell your LED to go on, or you can just set it at on so that your LED stays on. And you can also read inputs from it. So there are some sensors that will send digital input to your board. So your sensor will just send a 1 or a 0, and then you can detect those. The other type of sensor is an analog sensor. So analog sensors have a wider range. So they'll give you a value, or they'll be able to read the current that is going inside of that pin. And the value goes from 0 to 1024. And yeah, so it just reads that current. So what we're going to do here is that we're going to use a photoresistor. Photoresistor, as its name says, is a resistor, and the value of the resistance actually changes with the light that it's exposed to. So what that will do is that if there's more light, the amount of current going into the pin will be reduced, and the value that you read from that pin will be lower. And if there's more light or less light, it will go up. All right? So we have to split our current in two. So this one is a little bit more tricky to build. So just follow the blue lines. All right, so you need to pass it a 5-volt current into a LED and use the other LED, so the 1K ohm LED. Not the LED, the resistor, sorry. Right, starting from scratch. 5 volt into the resistor, the 1K resistor, so the one that doesn't have two red stripes. From there, you will go into any of the pin from your photoresistor, and you will also go back to A0, or just any other analog inputs. All right, and from the other pin of your resistor, you'll simply go to ground. All right? So it's a little bit more tricky, but the final result is so worth it. Right, I'll just move on to the code right away, and I'll come back to the schema in a few minutes, just because for those people that do not have a laptop, it's getting a little bit boring. I get it. So going through the code very quickly, once again, line by line. So you start by requiring Johnny 5. You require your board, same thing. And when the board is ready, you have this event that is being triggered. You declare your LED, so we'll still use our LED. And you declare your sensor. So Johnny 5 comes with another object, which is sensor, and you pass it the pin number. So in our case, we've used A0. Of course, it's a string this time, so make sure that you use the quotes. And the sensors have a change event. So whenever it detects a change, and it adds a little bit of like buffering, so it's not triggered every time, but quite frequently still. So whenever it changes, it will output a function, and you can get the sensor value. So the easiest thing to do first, you'll probably just want to do a console log sensor.value, and it will just spit out numbers. Like I said, ranging between 0 to 1024, and that simply indicates the amount of current that goes through that pin. And then based on that value, you can either check if it's upon a certain threshold, and it will really vary depending on where you are in the room, because there's a lot more light here in front than there is in the back. So check the values to see how much, what's the value that you're getting. Then you can turn it on or off based on the value that you're getting. Right, so this is the actual code. And then you can run it, and in theory, you should have your nightlight. So for those that are getting really bored, that's all I had. For the others that still want to stick around, we'll go back to the schematics, and I'll be here until 10 just to help everybody out, to hopefully get a few of them working. All right? I'm going back to the schematics, and I'll go back to the code in just a minute because there's a few people still wiring up the... or you can download the slides. You want to verify? Thank you.
What's the URL to get the slides?
So my GitHub username is Joel Lord, all in one word. So do GitHub/Joel Lord. And it should be iJS-Nodebot. Yep, the first one. Somebody's excited. Is it working over there or not yet?
There needs to be jump cable missing, right? Because you have to connect the one pin of the resistor with the 5 volt.
Yeah, you're missing one?
Yeah,
I've got some in the front. I'll be right back. Now, some people might be missing cables, so I have a few here with me. There's a way to rewire it and to refactor this, but... No, you're good?
Thanks.
Okay.
I could probably get the second one.
There you go. Thank you. Oops. It works. We've got one working. Okay, so go back to the code. The slide, the code. This one. Okay, I'll be right back with the cable.
Thank you.
How much? 3? Wow, you really need to refactor your thing there.
to have, for example, a Raspberry Pi that would run Node and then connect Arduino to it? And
You could do the exact same thing with a Raspberry Pi, basically, and it would run Node on it. And there are some input and outputs pins that you can use directly on the Raspberry Pi. So you don't even need an Arduino if you have your Pi.
no, for this example, yeah, but
For-
for some advanced stuff.
For something more advanced, you might want to use one, yes. I've heard some shouting of excitement there, so we got another one working. All right. See, it is fun when it actually works. It's like programming, exactly. I'm not sure if you'll actually have the time, but if you want to give it a try.
Got the modules to work, but the board never connects. Just looking for connected device.
It's not connected? Okay, so there was a, remember there was a slide with a driver or a URL? So try to install that driver.
I already installed it.
You installed it?
I have like he says you can find module formatter. It's like
Try with another board. There you go, for being the first one.
Thanks.
Is it working here?
Yes.
Good. How's it going over here?
Yeah, it works.
It works? Great. Cool. Thank you very much.